Koji Sato, the CEO of Toyota, paused mid-sentence as the overhead lights dimmed. The sleek form of the aquat engine now illuminated like some mythic artifact. It hummed quietly in the contained silence of the demonstration hall, seemingly powered by nothing more noble than a simple bucket of ordinary tap water. He didn't need to elaborate. The implication was clear. In that charged moment, an unspoken declaration hung in the air. This innovation could very well upend everything the EV industry stood for. Before we start, smash the like and subscribe buttons for more updates. Across Japan and then around the world, the ripples were instantaneous. Observers struggled to reconcile the familiar image of Toyota, quiet, methodical, almost conservative, with this electrifying revelation, an onboard electrolytic reactor that separated hydrogen from water in real time, feeding a compact fuel cell and delivering power with no fossil fuels, no grid, no lithium, just water. A closed-loop hydrogen system, clean and almost poetic in its simplicity. The engine consumed tap or rainwater, refilled in a couple of minutes, and promised over 900 kilometers of range. The future didn't come draped in wires and batteries. It came in the elemental purity of a water molecule. Immediately, questions swarmed. How could Toyota have achieved something so revolutionary so quietly? Sato's stagecraft was subtle yet powerful. He didn't scream that this was the end of electric vehicles. He let his creation speak for itself. The audience already understood. Refueling in 2 minutes with water. That alone dismantled years of infrastructure investments in charging networks, battery supply chains, lithium mining, and grid expansion. It was too elegant, too radical to ignore. Journalists scrambled for clarity. Was this a fuel cell? No. There was no high-pressure hydrogen tank, no external hydrogen station. The hydrogen was born inside the engine on demand. The only byproduct, water vapor. That meant zero emissions, zero reliance on battery materials, and no requirement for rare earth elements. It was molecular fuel, pure and simple. In the marquee corridors of the EV industry, the shock was seismic. Battery giants, once reveling in headlines about market dominance, now found themselves confronting a new paradigm. Lithium futures dipped. Stock charts wavered. Tesla, BYD, Rivian, all tentatively retreated into boardrooms, reassessing strategies. Traders whispered about stranded assets. Planners looked at charging infrastructure with fresh trepidation. At the same time, environmental groups erupted in applause. Here was a technology that offered a credible path toward decarbonization without further exploiting fragile ecosystems or inciting geopolitical tension over mineral mining. The possibility of mobility powered by water, a form and function fused with environmental ethics, had an almost mythic allure. Governments, initially cautious, now pivoted. Regulators scrambled to define safety frameworks. Was a sealed reactor that split water on board truly safe across temperatures, altitudes, and traffic conditions? What about use in cold climates where water freezes? Toyota's certifications, including Japan's top environmental and road safety clearances, assuaged many fears, but not all. Lobbyists raised alarms. If water-powered engines proliferated, what would happen to economies built on lithium, oil, or even electricity grids? Would desalination plants be repurposed? Would rainwater harvesting become a new focus? And all the while, Toyota moved forward with exceptional stealth and confidence. The aquat engines were already in production at the Higashi-Fuji plant. Plans called for the first vehicles, starting with the AQ, to roll out as early as the first quarter of 2026. Ambitions didn't end there. Commercial trucks and Lexus models were next in the pipeline. Exclusive patents on the electrolytic reactor meant competitors couldn't easily replicate the technology. Perhaps most intriguing was the modularity that hinted at future scalability. Toyota's engineers had designed the aquat to be adaptable, with core components that could be scaled up or down depending on the application. A city bus could house a larger electrolytic chamber for greater hydrogen throughput, while a compact urban commuter might operate with a smaller, lighter system. This flexibility meant the technology could saturate multiple transport segments simultaneously rather than waiting for a trickle-down effect from one class of vehicle to another. In research institutions, the unveiling triggered a renewed focus on complementary technologies. Advances in atmospheric water harvesting, for example, could pair seamlessly with the aquat, allowing vehicles to generate their own water supply in humid climates. New materials for even more efficient electrolysis could push the system's performance further, while AI-driven route optimization could reduce energy demands to the absolute minimum. The social implications were equally significant. In developing regions where access to fuel is often limited or prohibitively expensive, a vehicle that could run on collected rainwater or locally sourced non-potable supplies could transform mobility. Farmers, traders, and rural healthcare providers could travel farther and more frequently without the economic strain of conventional fuel costs. Mobility itself could become more equitable, no longer restricted by the location of fuel supply chains. As engineers demonstrated the ease of operation to small groups in the hall, it became clear that user interaction had been a design priority. A single dashboard indicator displayed water levels, projected range, and hydrogen production rate in an intuitive format. There were no complex controls for the driver to manage. The system's AI handled everything from flow rates to temperature balancing. The driver's only task was to ensure the reservoir was topped up, a task so straightforward it required no special training. For Toyota, the unveiling was also a subtle statement of independence from dominant industry trends. While other automakers were betting heavily on solid-state batteries or extended-range EVs, Toyota had stepped sideways into a space with little direct competition. This move insulated the company from some of the fiercest battles over battery supply contracts and charging infrastructure partnerships. It also positioned them as a supplier of not just vehicles, but of an entirely new propulsion ecosystem that others might license in the future. The room's atmosphere during those final hours was one of measured excitement. This was not the frenzied hype often associated with tech reveals. It was the quiet acknowledgement of witnessing a step change in what was thought possible. Industry veterans, normally skeptical of grand claims, found themselves discussing practical deployment timelines rather than feasibility. Startups whispered about pivoting to support services, from water logistics to aftermarket upgrades. Policymakers in attendance considered how existing fuel taxation models might adapt when water became a primary transport fuel. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us what are your thoughts on Toyota's new engine destroying the EV industry. We want to hear from you. Thank you for watching and see you next time.